Thanks for coming, guys. My name is Mike Wolfson. I am going to talk about Android developer tools. I recently, well, we'll get into it. Just wanted to give you a quick concept of what the agenda is so you guys have an idea of what we're going to be doing today. I'm going to start off with an introduction both about myself and about the tools. We're going to talk about the ADB and command line tools, Emulator, talk about some shortcuts for coding, and then we'll talk about performance monitoring and things like that. I just want to give you an idea. I've given this talk previously. I've given it a few times, but this particular slide deck came from OSCON. Their presentations are targeting 40 minutes, which is not a lot of time. So I've expanded it quite a bit for this presentation, but I think it'll go about, I'm targeting just about a little over an hour and 15 minutes. If you want to ask questions, go ahead and raise your hand and interrupt. Obviously, if I can't answer it or it's too much of a digression, we'll just move on and I'll answer it afterwards. I mentioned I've given this talks a few times at OSCON and DevCon, a few other places. Generally, I have had live demos in the presentation. When I did this talk for OSCON, I put all the demos kind of as slides, and everything went so much smoother. So there won't be a lot of demos, but if there is something that in particular you want to see, we can do that afterwards. I'd be happy to show you how to run any of the tools specifically, how to run any of the demos, any sort of questions. So, we'll tackle that afterwards. Okay, so just a little bit about me. I guess the most important thing about me is I run the Phoenix chapter of the Google Developer Group. I founded it. I've run it for I don't know, I don't know how many years, but anyway, that's I run a Google Developer Group in Phoenix. I love the community, and I love just getting people together to talk about tools and stuff. So I'm also a full-time Android developer. I currently work, I live in Phoenix. I work for a company here in Silicon Valley in San Mateo named Hippocrates. They're a healthcare point-of-service app. Some people maybe have heard of them. And I am a full-time Android developer. That's what I do in my day job, and that's also what I do for fun. So I've been lucky enough to find a job that allows me to do my hobby for fun. Previous to that, I have about 15 years of experience, mostly in enterprise Java development. So for the first book, can anybody tell me what's unusual about this picture?
Why is there's like a piece of paper on the text?
Is there a cheat sheet? Oh, I see Kit Kats behind it.
No, that's an ice cream sandwich. Okay, well, actually the statue is not correct anymore. The Jelly Bean statue was changed. This picture was taken the day that the Jelly Bean statue was unveiled, and they changed the top of that. It doesn't have a clear dome anymore. Now it's got a clear green thing on it. So there will be other chances to get books. I also want to mention, if you guys don't particularly want a hard copy of the book, I'm more than happy to make the soft copy available for download for free. So just keep that. That's great. So obviously that's between you and me and not O'Reilly. But anyway, but I do want you guys to know that if you really are interested in the book, come up and talk to me afterwards. I'll give you the URL where you can go download. I have all 4 different types of DRM-free books in my Dropbox. So I'll share that link. So, I just want you guys to know that. Okay, we talked enough about this. I just published this book for O'Reilly. It's been out about 4 or 5 months. So I've always been passionate about the Android developer tools. They sometimes have some challenges in understanding how to use them and how to run them. So I figured it would be a good topic to share because I think it's really important. I think the tools are really fantastic, and the project and the team are really great. I think the discovery and usability of the tools, not usability, but the discovery it can be challenging. So that's why I wrote the book. The other thing is I am an active developer, and for fun, I have an app in the market called Droid of the Day. It is a app of the day app. Basically every day you'll get a notification of a new app. It's been in the market for quite a while. It's got a decent number of downloads, and it's free. So if you're interested in apps, check it out. The other thing I'll mention is if you are an app developer and you'd like to see your app featured, this is a good way to get visibility. And part of the reason that I run this app is because I like to help independent developers find an audience, which can be challenging in the Play Store. If you're a developer, let me know and I'll see about featuring your app. Okay, real quick, I just wanted to tell you a little bit about some presentation resources. These slides are all available up on SlideShare, so they're available. There's an old copy there now. After this presentation, I'll make sure I upload the newest copy, but that's what the URL will be there. The other thing I wanted to mention is when writing the book and for this presentation, I did generate a project, Android project that is designed to help run the demos and generate examples. So it's up here at GitHub. So if you want to download that, that should help you run all the demos. And you'll see throughout the presentation there are certain times where I might reference that. So in regards to that, anytime that you see a gray box down at the bottom with in that style, that's going to infer it's a tool, it's something for you to try at home, or a command to type in. So when you see that box, that should key you in to know that you have homework. Okay, so that's enough about me. Let's talk a little bit about the tools, and then we'll get into the nitty-gritty of actually using the tools. So the first thing I want to mention about the Android developer tools is that they are free and open source. So I don't want to make a political statement about Android, but the Android AOSP is realistically not open source. They don't take submissions, and it's not developed in the open source. They give it to the open source community after it's been developed. The difference is the Android developer tools are developed completely in the open. There is an open branch that you can go check out the latest revisions of the code, and they do take submissions. If you have a fix or something, they do accept submissions. So it's a much different sort of project than Android. And the other thing that's important to mention is it's run independent of Android. They're not necessarily the same team. They're run differently. They have different schedules, and they have different kind of ways of operation. So they're very, very different. Tools.android.com is the location where you can get all the information you need about the tools. I will also say this about the tools development team, is they're very open and very available. You'll see that they're answering questions in group chat. They're not very secretive, and they're very open. So it's a really great team, and they seem to be run really well. And I think they've done a great job. OK, so let's talk about the tools a little bit. I think you guys are probably all familiar with the Eclipse-based ADT. That's basically the tools that we've been using for many years now. Very, very stable, very rock solid. At Google I/O this year, they introduced the Android Studio. Android Studio is a new flavor of Android IDE, and it lives alongside of the ADT, Android Developer Tools. Now, I do want to say something very important, and I have verified this. This doesn't mean that the Eclipse-based tools are going away. It just means that there's a new flavor involved. We can talk about why they're doing this if you'd like after the presentation. But when this first came out, a lot of people thought, "Oh man, now I got to learn a new tool. Eclipse is going away."
So is Tor Norby a member of this tools group that you're speaking of?
Yes, absolutely. Tor Norby, Javier Durocher. Those are the two big names that I think are the most representative. So it's important to know that just because they introduced Android Studio doesn't mean that Android developer tools are going away. The Eclipse-based tools are extremely stable, they're very feature-rich, and they have a huge user base. There would be no reason for them to abandon that. And to drive this point home, they're not abandoning Eclipse. So let's give a little analogy of the difference here between the two tools. So I kind of consider Eclipse like a gold Camry station wagon. Really reliable, rock solid, is going to get you where you need to go, but you may not look that great getting there, and it may not be that much fun to drive. Whereas the Android Studio is much like this Ferrari F430 that is rockin' fast and handles great, but if you don't know what you're doing, you're going to wrap yourself around a tree.
It's lighter than Eclipse too.
Yeah. Android Studio is definitely the sexy hotness, quick, but if you don't know what you're doing or you don't necessarily have a reason to be using Android Studio, I would strongly suggest that you stick with the Eclipse-based tools for now. They're stable. There's a huge community of support around them, and great. All the questions are answered, things like that. And we'll talk just a little bit more about what Android Studio is. Did you have a question?
So how much of the code base between two is common? What percentage?
I don't know about a percentage. I do think some of the tools are common, but I don't think they share a lot together. But I would have no way to know the percentage.
Can you repeat questions?
Oh, sure. Sorry about that. The question was how much code is shared between between Android Studio and ADT, and the answer is I don't know. Okay, so let's talk a little bit about Android Studio, what it is, so that you kind of know some of the key differences between that and the Eclipse-based tools. So Android Studio is based on the IntelliJ IDE, so a completely different IDE, has different key commands, different way of doing things. It also implements under the covers the new Gradle-based build system. I just want to mention about the Gradle-based build system. You don't have to use Android Studio for Gradle. You can also run your builds, your Eclipse builds, using the Gradle build. And if you look in the file export, you can actually export out of Eclipse. You can export your Gradle build file. So if you want to play with Gradle, which is a whole nother discussion that we're not going to get into what Gradle is, I would strongly suggest that you start thinking about Gradle. I mentioned that Android Studio is not replacing ADT. Gradle is replacing Ant. So they have said that Gradle is their future build system and that Ant is deprecated. So you want to start using Gradle, and Gradle's really well designed for Android. It allows you to generate all sorts of different builds just right from the build tool, things like that. So. Again, I'm not sure I'd suggest using Android Studio. I would suggest checking out Gradle and trying to come up to speed on that. I think that will benefit you. One really great thing about Android Studio is they have a really rich visual editor. So they have a real-time visual editor that will allow you to make changes in your code and look at the changes as they'd be represented in your UI directly. So they also have a really rich drag-and-drop UI builder. It's clear that that's like something that you get really good out of Android Studio. The other thing is they have really good integration with Google Cloud Services. I haven't done this myself, but what they demoed at I/O was you could look at your data model, right mouse click on the data model, and generate code that would allow you to create a sync to the Google Cloud Services. So pretty cool stuff. And no doubt Android Studio is going to really keep innovating, and we're going to see a lot of movement with Android Studio, and not as much as ADT. But for now, and this is the last bullet, it's still an early access preview, which means it's alpha for the most part, not even beta. It is buggy, it is certainly in flux, and it is not for the weak of heart. So. So I think statement made. Yeah.
How stable is Gradle build system? Using now?
I would suggest using Gradle now. Yes. It is stable. Yes. I don't know. It's still also pretty dynamic, but I would suggest using Gradle now, and I do think it is stable enough to be production quality. There's probably going to be some features that aren't implemented yet, but maybe if you're an early adopter, you can help drive some of those things by communicating those needs and things. So I should have done this earlier. Can I just see a show of hands of how many people are active Android developers now? Great. And how many of you people are really comfortable with the tools and think you really know how they work? Okay. Okay. Well, I do cover a lot of the basics, and I added some more advanced stuff to this presentation. So hopefully, I will, have stuff of interest to everybody.
So the nice thing about Eclipse is that it's both Java and C, so it's easy to create if you need to C libraries that are called Java. Does IntelliJ, does Android Studio offer the same capability?
Well, yes. IntelliJ is an IDE just like Eclipse, so you can do different projects of all different flavors, web projects, C++ projects.
It's like a dashboard in a Volkswagen. You're used to the dashboard, you just keep using it.
Yeah.
The Volkswagen is coming.
Yeah. Okay, so historically, if you wanted to install the Android developer tools, you had to download a bunch of different components, the plugin, the IDE, the Java, etc., and then wire them all together. Fortunately, this has all gone away. And now, for both Android Studio and Eclipse, there is a downloadable bundle. And this allows you to just download one platform-specific zip file, install it on your system, and everything works. So the reason I want to include the reason I included this in these slides is because it's really important. If you're working with an old Eclipse, if you're working with an old Android installation and you're scared to touch it, and every time you upgrade it, it's fickle and you have issues, wipe it away. Delete that completely and start with a bundle, because it is so easy. In fact, frequently, if I do have those problems that I can't get an upgrade to work or whatever, I wipe away my Android installation completely, download a brand new bundle, which is going to have all the current latest code already in there and working. So don't be afraid of the bundle, and if you are having any challenges, don't be afraid to just wipe your system and start fresh. The only challenge with the bundle is it's about 400 megabytes download. So the biggest problem is getting that big download the first time. After that, it's as easy as could be. Okay, so I'm going to move on to the Android Debug Bridge. Android Debug Bridge is kind of what the name says. It is a bridge that allows you to debug your Android device from your computer. So this is basically a command line tool and also a communication tool that allows us to interact with our Android devices. The important thing to note here is in Android, an Android test device can be an emulator or it can be an actual physical device. And for the most part, there's not a whole lot of difference between those two things. So this is one of those cases where you see a gray box that allows you to, these are some commands I would encourage you to try on your own later. Obviously, ADB Help is super simple, but you can see the kind of things that you can do with ADB. You can push files from your device, you can pull files, you can install an APK and run an APK. There's a lot of more advanced stuff you can do. You can actually install an APK and run a single activity, and that activity doesn't have to be the main activity in your manifest, the one that is marked as your main activity. Ton of flexibility. Now the cool thing is, because these are command line tools, that flexibility is available to you to script or without any sort of rich UI. I assume most of you guys have used ADB. The other really common use for ADB is if you're ROMing and rooting your phone. Obviously, ADB is the main tool you use to do that, to unlock your bootloader, to push files onto the phone, things like that. So there's a ton of stuff you can do. I'm sorry, the one last thing I wanted to point out was this one at the bottom, which actually allows you to, well, there's two things. There's two last bullets. The first bullet, ADB shell, allows you to open a shell command on your Android device and operate any of the commands that are involved in a shell, ls, mv, etc., etc. Now, the shell that comes with Android isn't a complete Linux shell. It doesn't have all the commands that a regular Linux shell has, but you can do a whole lot. And ADB shell allows you to actually remote into your device and do any sort of things that you want. Look at the system, inspect files, etc., etc. But the really cool thing it also allows you to do is you can open a SQLite command and introspect your databases. So if you are doing database command and you want to figure out what's in your tables, your table structures, etc., there's a SQLite command that allows you just as if you were using SQLite on any other system. The other really important thing that we do with ADB is Logcat. I'm sure you guys are all familiar with Logcat, but I would guess that you're not familiar with all the things that it can do. So I just want to run through a really quick example of some simple stuff in Logcat, explain how it works, and show you some advanced stuff. So the first thing you can do with Logcat has two sort of concepts. The first concept is a verbosity level, just like you guys, I assume you guys have used log4j, where you can set the debug level to verbose, debug, etc., warn. That same concept exists in Android, so you can set, when you create a log statement, so like this one in my Java class, you can set a verbosity level. In this case, I have D set, so debug. But the cool thing about Logcat is you can also associate a tag with your log message. So in this case, I have this my tag tag and then the log message. What this allows you to do is you can filter based on the tags that you create in your code. So generally what you do is when you're writing your code, you create tags that are specific to functional areas that you want to test. Then you can filter based on those tags and see how your code progresses through that particular functional area. So quick example, this is a Logcat where I have not performed any sort of filtering based on it. If, again, I'm sure you guys have looked at Logcat messages. There's a ton of stuff that goes through, especially if you're using a real physical device. There's all sorts of system events happening. If you want to see what you're looking at, you got to look real closely and you got to look real careful. So you can see I have those tags, but if I didn't have them highlighted here, they'd be pretty hard to figure out where they were. So all you'll do is, if you do want to see if you do want to see Logcat related to your particular tags, you just issue a command, ADB Logcat my tag :0. Then the important second part of that command is the not colon, the star. I'm sorry. So tag : star. The first before the colon is the tag. The part after the tag is what verbosity level you want seen. So in this case, I say I want all verbosity levels for tag. And the second important thing is I want to silence everything else. So that's what the star : s means. And when I do that, you can see that now I can very clearly see exactly what I'm looking for, and all the fluff is gone. Now, that's pretty cool. You can filter based on a single tag, but the important thing is you can filter based on multiple tags. So in this case, this example shows I'm filtering based on my own unique tag. I want to see my tag, but I'm also interested in seeing how my tag relates to package manager. So basically, you create that command, my tag : package manager : and then don't forget the *:s to silence everything else. And you'll see now I have just the information about the 2 tags that I'm interested in. And you could create as many different filter sets as you want. You can string multiple sets. And of course, you could also filter based on a tag and a verbosity level combined. So there's a ton of flexibility. And if you design your tags, if you design your log messages with these tags in mind, it is an indispensable tool when you're trying to debug. It allows you to really drill down to see just the stuff you care about and remove all the other fluff. So that's just basic Logcat. Did somebody have a question? Okay, so that's just basic Logcat, but you can do a whole bunch of other stuff with Logcat, and I leave this slide for you guys to try when you're at home. You could also, if you're interested in only a particular buffer, like radio, like the radio buffer or the events buffer, or the main buffer, which is the default in this case, you can specify a particular buffer that you want to see. So you can filter so you're only seeing the radio buffer. That's the only messages you care about. Obviously, that depends on the type of code you're writing. There's also a variety of predefined output formats. So brief is the default, and that specifies different parameters that will be output. But time is a really useful one that appends a time, which isn't in the basic log functionality. So, and again, you can add these command lines, these command line arguments in addition to the tags. So as you can see, there's a really rich set of Logcat functionality. The last thing I'm not going to demo, but is really worth exploring, is the Logcat tab in Eclipse. This allows you to save a bunch of filter sets and tag sets, so you don't have to type them every time. You can actually save a tag set and click on it, and it will filter based on that. And the other really cool thing that the Logcat viewer in Eclipse has is a regex editor. So you can actually search your logs using regular expressions, which again is really rich. So as developers, I'm sure you guys all realize that logs are really important, especially when you're in the midst of trying to figure something out. And Logcat really allows you to get at exactly what you want to see. Good. Okay, so that's Logcat. Let's now talk a little bit about emulators. I want to address, first of all, some of the capabilities of emulators, and then we'll talk about some of the limitations. First thing you can do with an emulator is you can simulate telephony. So you can simulate latency or connectivity, or simulate events as in a SMS or a phone call. You can't actually make a phone call, but you can simulate a phone call. You can simulate location, including KML or a path. You can specify a single location that your emulator is supposed to emulate. You can emulate a variety of different hardware. Now, that's the important thing, and the reason why we want to use an emulator is there's a lot of Android devices in this world. I think the last time I looked at my Droid of the Day console, that my app currently supports like 3,000 different devices. Even if I was really, really rich, I wouldn't be able to purchase all 3,000 of those devices to test with. So using an emulator allows me to simulate a variety of different hardware configurations so that I can at least get close and know for the most part. Now, there are some limitations, I guess, which we'll get to in a second on emulators. Yeah,
so
go ahead.
To emulate all the different resolutions of the different devices, can you do that? How accurate is it?
So the question was, if you want to emulate different resolutions of devices, can you do that, and how accurate is it? That you absolutely can do. You can actually, I'll show you in a second when we're setting, when I show you how you set up an AVD, you can specify preset resolutions, or you could actually create your own. So for resolution, you absolutely can emulate it exactly right. What you can't do, we'll get to in a second, what you can't do is emulate the skins that the manufacturers put on their devices. So TouchWiz, MotoBlur, I guess, I don't know if that exists anymore, but TouchWiz or LG's skin, those you cannot emulate in a emulator.
Is it better than like taking a Nexus 10 and using the ADB?
Well, actually, that's now a little different thing. So the question was, there's a process that you can use with the Nexus 10. Using ADB, you can actually have the Nexus 10 emulate different resolution sizes using some commands. So the question was, is that a better approach, or is using an emulator a better approach? And the answer is it depends. Go ahead.
Locations, what are the different options? Are they based on GPS coordinates or CT level or IP level?
It is lat long. It takes lat long, KML, and one other type of format of I can't think of the third. GPX? Is that a? What is it? Okay, well, there's 3 types. I'm not sure of the third. Yes. The question is, does the ARM emulation basically does it perform the same as a real ARM phone? Is that your question?
Yeah, some of the ARMs have performance counters, so you can figure out
So the question is, does the emulator perform the same as a device? I think I'm going to, the answer is no, definitely not. If you're doing really performance testing, you probably want to use a real device. There's so many variables in an emulator, both the device, the physical device it's on your computer, how many other things it's working on, et cetera, et cetera. The performance is not going to be accurate to what you would see on a real device. So
Intel is investing on the Android market big time. I think it would be a good idea to use x86 emulator just to test how it works on x86 chipsets.
yeah, so the comment is, in addition to AMD, you also may want to test using the Intel chipset because there are Intel phones around, and I'm actually going to discuss that in a second because there's other advantages in addition to just emulating Intel chipsets. So I'm actually going to touch that in a second. Last thing you can do with emulator is you can do media actions, but only audio, not video. You cannot do video on an emulator. Some of the limitations of things you cannot do on an emulator include Google services like Gmail or the Play Store, things like that. You can now there are ways to hack that onto the emulator. There are ways to work around this issue, but out of the box, it is not designed to run Play services, and I think there's obstacles, and there will continue to be obstacles. They don't want that on the emulator. You can't make real phone calls. I think we already kind of discussed that. Certain graphics support, again, this is getting back to kind of what we were discussing before. The performance is not the same, so if you're doing a game or something that requires very precise graphics performance, the emulator is probably not the right place for you to be testing your functionality. The other thing that's limited on an emulator is touch events. You have a mouse to interact with your device, so multi-touch or certain other operations are limited. You just can't do that.
So for multi-touch laptop, multi-touch screen laptop, they're going to support that in the future.
So.
That's it.
Yeah, so the question is using either a video touchscreen monitor or a computer that has a multi-touch keypad. Will they support multi-touch in the future? I don't know the answer to what they're going to support in the future. There is a ADB bridge that allows you to use your device as a touch sensor for your emulator. So again, it's one of, as I'm sure everybody in the room knows, and anybody that's done professional Android knows, when the question is, does Android do it? The answer is always yes, because it's such an open platform. There's always some way to get what you want done. If you have enough time, money, and resources, you can do pretty much anything you want with these things. But you know, out of the box, it's not supported. There is limited accessory integration. You can use USB and headphones. And the other big limitation of emulators is they're really slow. Slow to start, they can be slow to deploy to, and they can be slow to run. So I am going to show you some tips on how you speed it up. But again, I'm sure everybody in here knows when you start your emulator, it's time to go grab a cup of coffee. Or go check out Facebook or whatever, because you're going to be waiting. It can take 3 minutes for an emulator to start up. Okay, yeah, go ahead. So the question is it possible to emulate Bluetooth? I don't know the answer to that. I would suspect not, because that. I don't know. I was going to say because the computer hardware would require Bluetooth. Of course, most computers now have Bluetooth. So I don't know if you can emulate Bluetooth. That's a good question. In fact, you get the first ball. All right. So as I mentioned, there's lots and lots of Android devices in this world. Every device on this screen, it runs Android, and or at least interfaces with Android. So it's really important that you understand emulators and understand how you can use them so that you can be able to test on the biggest variety of devices possible. I think in a professional world, this doesn't excuse you not having a variety of actual devices to test on, but emulators will get you a good distance of the way. So let's talk for real quick. We'll take a quick diversion. Let's say that you don't want to use an emulator. You can use almost any Android device as a test device. There may be very few exceptions, but for the most part, any Android device works as a test device. The only thing you need to do is enable this checkbox in your device settings app. So basically, you just need to allow your device to run applications from outside of the Play Store, and you can run any app you want on your Android device. I'm sure there are some, maybe I assume probably the Kindle Fire doesn't allow you to do that, some other things, but for the most part, any device is available now. The challenge is after OS 4.1, they hid, I'm sorry, so that particular function, actually, I'm not sure if that function is hidden in developer tools or not. But that's the step one. Step two that you're probably also going to want to do.
It's not.
Good.
It's in the main area.
Oh, okay, great. So the allowing apps from non-Play Store is not hidden in the developer tools. But you're going to want to access the developer tools, enable the developer tools on your device so that you can debug directly into the device, hook up a USB, things like that. In addition to some other things. Now, the challenge is in OS 4.1, they hid that. So that this used to be an item that was available in your settings app. You just had to go find it and enable it. Now it's hidden. So the way to get there now is you click on the About Phone button 7 times, and at the end of the 7th time, you get a nice message that says, "Congratulations, you're now a developer," and that shows up in your list. So.
Start hitting, it'll go like 4, 3, 2, 1.
Yeah. So the comment is, once you start hitting it, you'll see click 7 times, 6 times, 5 times, 4 times. I'm not sure, but I think that might move actually what you have to click. But basically, I thought I might have had to click the build for KitKat.
It was About Phone when I rooted my 7, so that was for KitKat. So.
Okay. Okay. Good. So anyway, that's what you want to do now. The cool thing is, basically what I just told you is how you can use your phone as a test device. But the developer options that I just showed you how to enable have a ton of really great functionality in them. in it, and it's all based on testing on your device itself. So obviously USB debugging allows you to hook a USB device into your phone. That's pretty normal. But the other things you can do in there, and I really encourage you guys to go look in the developer options and just start playing with these things, are allowing mock locations. So that allows you to specify you know, some of the locations we were just talking about. Strict mode allows you to flash your phone. It flashes your phone red when you're doing operations on the main UI thread, which, as good Android developers, you know, you never want to do long-running operations on the UI thread. So there's just a checkbox there that allows you to quickly see, and it's really obvious. In fact, I run this all the time. I have strict mode enabled on my device all the time, and it's interesting to see how many you know, apps are being bad. But as a developer, it's really great for you to be able to see when your app is being bad, and it's really in your face. You can show touches, so if you're doing a presentation or something, it will highlight the touch points you're pressing on your device. You can change the animation and transition scale so that you can get a closer look at the animations that you're using, and if you're debugging those. You can also select, and this is just a small list, there's a lot of stuff in there. You can also, don't keep activities, so this will kill the activity as soon as it closes, which allows you to mess with state if you're doing particular operations. So the developer tools are the developer options that are on the phone are really, really rich, and something that most people don't use, but something that you should. And they're really low risk to play with. Just go enable your phone, go start playing with those things. You're not going to mess anything up. Basically, these are just visual cues and things. But I think you'll learn a lot running your app and enabling some of these different developer options. Okay, so remember all these devices, and remember that we can't possibly afford to buy them all. Let's say that we just want to concentrate on that top little area, the phones and tablets. That's when we really want to start talking about using emulators to emulate some of these different physical devices. And so I want to go ahead and talk a little bit about how you set up an emulator, some of the different options you have, and also how we go about speeding up emulator things like that. Okay, so the first step you want to do when you're creating an emulator is you're going to create something called an Android virtual device. So this is basically just a representation of the physical device that allows you to specify a variety of different things that you want your particular emulator to look like. So you'll notice in this case I have it emulating a Galaxy Nexus. I can specify which particular OS I want to target. I can specify which particular CPU I want to target. Currently, you can select between ARM, Intel, and a third. NIPS. You can specify hardware, keyboard, things like that. If it has a camera, if it doesn't have a camera, memory footprint, and you can also specify SD card, things like that. Now, there's a couple options at the bottom that I want to particularly call out because they're particularly useful and particularly functional. The first one is used host GPU. So this allows you to, if your computer has a GPU, it allows you to leverage that to improve the performance of your emulator. So it will attach to it'll attach to that GPU. I think that that's only available if you're using the Hexam emulator, the Intel. Is that correct? I think you can only use the host GPU if you're using an Intel emulator, which we'll get to in a second. But the other really great thing is Snapshot. So if you guys know what if you guys have ever used any virtual machine, VMware, etc., when you close the virtual machine, there is functionality that allows you to save a snapshot of that virtual machine. So the next time you bring it up, it brings it up to that same place. That's exactly what this snapshot functionality does, because these are basically virtual machines anyway, these emulator images. So when you're creating your AVD, if you check that snapshot button, it allows you to enable these snapshot functionality. Then when you're launching your AVD, you can select these three buttons here at the bottom, which allow you to use the snapshot. So the first time you bring up your emulator, you will wipe user data and then have this Save to Snapshot button enabled. So generally what I do is I bring up an emulator from scratch. I go through the various startup options that it presents you. Like there's the overlays that say, the Android overlays that say, press OK to put your put apps here or whatever. I go through all those startup options. So I have a fresh emulator that has been started up, and I've gotten through all these startup dialogues, and then I kill it right there, so that I have a pristine emulator that has been started up and is in brand spanking new fresh state. Next time when I start my AVD, my emulator, instead of having wipe user data selected, I have launch from snapshot selected and not save to snapshot. So next time when I start up this emulator, it's going to start it up using the snapshot that I just took. And the great thing is it changes the startup time from, like I said, 3-4 minutes to seconds, maybe 10 seconds, 20 seconds. If you're not using snapshots, this will, in fact, if you leave here now, you just learned something really good. Snapshots will save you a lot of time. The other thing you can do using snapshots is if you do have a particular state in your app that you want to test repeatedly, you can bring your app up to that state and then save that state as your snapshot. So you can always bring up your fresh emulator to exactly the point in the code that you need to test. Okay, so we kind of touched on some of these things before, but there are alternatives to using the Android emulators. First one is Intel's Hexam. So this allows you to create emulators using the Intel chipset. So if your computer is running an Intel chip instead of an AMD chip, this is a great way to. This is a great thing to do. Now, performance-wise, it's fine. But the Intel Hexam emulator is much faster to start up and much faster to deploy to. So right there in and of itself, it is a much faster experience to be using the Intel Hexam emulator. Big giant limitation of Hexam is that it doesn't support the the Google APIs. It only supports the Android APIs. So if you're doing anything that requires the Google APIs, GCM, or some of the other options available to Android, Intel Hexam is unfortunately not available to use. So if you're not using the Google APIs, Intel Hexam is really great. I would really strongly suggest you use it. It supports snapshots just the same as the standard emulator. So there is also another newcomer on the block called Genymotion, and they provide basically a turnkey options for generating emulators. So instead of with Hexam or the standard Android emulator, I have to go through create the emulator AVD that I think is appropriate to my needs, start it up, etc., etc. Genymotion provides a really rich GUI that allows you to start from a variety of pre-configured emulator images. The cool thing about previous version of Genymotion, and this has just changed with their new release, is the last version of Genymotion actually did support full Play services. So it supported the Play Store. You could create a Google account on a Genymotion emulator, all those things. Unfortunately, it didn't last long because they just announced in their next release that that's going away. I'm pretty sure, and of course we don't know because Genymotion is a closed project, I'm pretty sure they use Intel Hexam. It's really fast, it's really robust. The cool thing about both Intel Hexam and Genymotion, and this is one of those things that you might not key in on early but really makes a difference in the development process, is the deployment speed. So it takes a little bit of time to deploy to an Android emulator. Both Hexam and Genymotion, the deployment time is much more rapid. So those are some things that you might not key in on early. But it makes a big difference, especially in your daily development cycle that you're deploying. So, oh, one sec, this guy.
You said AMD several times, but you actually meant ARM, right?
Yeah, ARM. Sorry. The question is, I've been saying AMD. Do I mean ARM? The answer is yes.
Is the Android Studio has the same emulator, or is there anything better in the Android Studio?
Android Studio uses the same emulators, and I'm pretty sure you can use Genymotion or Hexam as well on Android Studio. Okay, so that's enough of the tools. Let's talk about coding. There are a ton of really great tools built into the ADT that, if you use them, will save you a lot of time and a lot of mistakes. Android, as again you guys all know, can be pretty challenging. There's a lot of moving parts. You have your XML file, your Java file. You have other external configuration files for certain operations that you're using a fragment. You have multiple Java files all connected. It can be really challenging, and if you mess up one piece, one attribute in that XML file, it can be a bear to try to debug that. There are a ton of automated code generation tools that I'll show you in a moment that at least allow you to stub out your initial code so that you're not fighting the basic stuff and you can concentrate on the business logic and the important stuff as opposed to creating these foundations.
So Gradle's made that easy.
Gradle?
Yeah.
How so? The comment is Gradle made this easy.
It's not too many moving parts.
Oh, yeah. So,
Studio.
right. Yeah, Gradle does make some of these configuration things easier because of the nature of their resource. You can build multiple APKs from different resources within. Yeah. So there's really great support for Java and XML editing that you can take advantage of, and there's also a really rich, robust visual editor that most people probably don't use because it used to kind of suck, basically. Okay, so let's talk a little bit about some of the code generation wizards that you can use and why you really should be using these things. So to access any of these wizards, you can hit File, New at the top, or Control or Command on Apple N. That will bring up this wizard selection. You can see there's a variety of different things you can do in there. You can create an icon set. You can create a simple activity. You can create an Android XML file, a variety of different things. These are really robust tools that will allow you to just create simple code that you can then go in and fill out yourself later. So let's start with the first example, and that's Android icon set. So again, you guys all know what a hassle it is to come up with all the different versions of your icons. You need to, first of all, figure out what size do they need to be, what folder do they need to go into, do I have XXHDPI for this one, et cetera, et cetera. It's a real challenge, not to mention trying to communicate that to your graphic designer or someone else on your team. This Android icon set, and the other thing I will mention about this particular tool is there's a really, in fact, this tool's good that's built into Eclipse, but this tool is based on a web project called Android Asset Studio. Android Asset Studio, remember that. It's a website that not only will allow you to create your different resolution images, but it also, Android Asset Studio, the website, allows you to create frames for your screenshots or a variety of other different really great things. So this is just a subset of what is on that website, but let me just show you what this particular thing allows you to do. So once you've selected create an icon set, it's going to allow you, it's going to bring up this wizard. Basically what this wizard allows you to do is you could select an image, that's your own icon that you can go select from anywhere on your system. Clip art, this is the Android standard clip art. So if you want to make sure that your settings icon matches what the Android settings icon is. It's all there for you, and it's built right in. Or you could create a text one, which is what is shown here in this example. So you can select your different icon, what you want your icon to look like. You can specify colors, change all sorts of different things, change the padding. When you press finish, it actually will create the icons and place them within your project in the folders they're supposed to go. So it's going to create a LDPI, HDPI, etc. image in the proper resolution, and also it's going to put those in the proper folders with the proper name. So the best way to import images into your system, even if your designer has given it to you, is bring up the image using the image option, and then allow Android to, Asset Studio or Asset to put that into your project for you. This saves a whole lot of time, and just another workflow thing that I use that has been very successful for me. When I'm creating my graphics, I generally know what name I want to use and what graphics I need. So what I'll do is I'll create a stubbed out graphic just like this, maybe AA or something red and ugly. Name it the proper thing, put it in my resource folder. Then I actually give that resource folder to my graphic designer and say, here's what I need. And they know exactly what size images they need to do, and they know exactly the names. So they can then put all those images into that resource zip, give it back to me, I copy it into my project, and I'm done. There's no imports, and all the names match and all the sizes match. So that's something that has taken me a long time to come up with, but saves a whole lot of time. It's really challenging to communicate all the different resolutions. Okay, so that's Android Asset Studio. That's creating an asset, and that's really, really useful. I suggest everybody use that. You can also generate great code with these wizards. And here's one of the more complicated ones, and it's a very common use case, and that's multiple fragments with a list view on one side and a detail view on the other side. And if you guys know about Android development, there's an adapter involved, there's there's an activity, 2 fragments, and then all the wiring that goes between those things. Some XML files. There's a lot going on here. This wizard allows you to walk through a couple different questions, specify the names of the items you want and the activities that you're creating, and it will generate the stubs for the code that you want to generate and place that directly into your project. So even it's just a great first step to allow you to stub out all the things, the wiring and the hard stuff, and get down to the nitty-gritty of writing code. And ton of stuff to explore in these code wizards. The other thing I just want to mention, so if you're not happy with the code wizards that they provide, you can actually create your own. So frequently in the development process, we create our own sort of frameworks and components that fit our particular business case. You can actually create your own template and allow your developers to just use the template to stub out these foundations. So really useful, and it's these sort of automation things that just make the development process so much more efficient and so much more effective. The last thing I might mention about generating code this way is it's all generated to code compliant Android design patterns, right? So the naming standards are matched, the division of workload, etc. So it's a really great way to get started. Wanted to highlight 6 of the most important keystrokes I use in Eclipse, and these are ones that I use all the time. The first one you guys probably know about, and that's code completion, control or command space. This works in both Java and in XML. So if you're trying to figure out what attributes you need in your XML file, was that wrap content or fill parent or match parent, I don't forget. Android:width equals control space, and it'll give you the list of all your different options that you can put in there. So that works in both Java and XML, and I'm sure you guys already know about that one. If you don't, that will probably change your life. One that you probably don't know about that's also extremely useful and that's kind of universal is Control-Command-1. So if you highlight anywhere in XML or Java, you highlight a particular component and hit Command-1, it's going to provide context-sensitive help based on what it is that you've selected. So in some cases, it may allow you to extract that string to the strings file. We don't want to leave hard-coded strings in our Android files. We want to extract those to strings.xml. That's something this will allow you to do. But depending on what it is that you've selected, it will provide context-specific things. So there may be refactoring help if you're on a layout parent, or depending on what you're doing. So if you need help, highlight something, Command-1, and it will provide you a lot of different functionality. And then the last one on this page is Command-Shift-F. This allows you to reformat your code to change indentation or change the formatting. The cool thing is this has specific functionality for XML. It will change your formatting, change your tabs, etc., so everything lines up. It will also reorder your XML attributes. So if generally you want width and height to be the very top attributes, ID, width, height to be the top attributes, etc., etc. There's an order that you want your attributes in, and if the coder's not careful, the attributes are all out of order. Control-Shift-F will actually reorder all the attributes so that they are in exactly the order that the Android design standards specify. And if you don't like that order, you can specify your own. So Command-Shift-F is really useful both in Java and XML to ensure that your formatting is consistent with, consistent with Android, and also consistent across all your entire project. Great navigation. So these items were key combinations that will allow you to create code and speed through some of these things. This page covers navigation commands. So the first one I wanted to talk about is Command-O. So anywhere within a XML file or a Java file, if you hit Command-O, it will show you a outline view of your code with the methods highlighted, so you can quickly just navigate with your arrow key to the method that you want, rather than trying to search through your code and scrolling up and down. Command-O, quickly look for the method you want to go to, click on it, and you're there. Another great way to navigate around a project is Command-Shift-R, or T actually, which has a Command-Shift-T has a more robust filter set. Command-Shift-R, from anywhere in your system, you can start typing the name of a file you're looking for, and if you're using camel case, you just use the first letter. So a camel case means uppercase C-O-D-E, uppercase P-R-O-J-E-C-T. You can type CP and it will find that code project file. So Command-Shift-R is a really great way to quickly find different files that you're looking for. And then the last one that's really useful is Alt-Shift-A. This allows you to quickly run or debug your app without having to right mouse click on the project, run as, or I don't know if you guys ever noticed, but there's a little play symbol up in the Eclipse toolbar that allows you to also run really quick. That's another quick way to do it. Alt-Shift-A allows you to quickly run your app from anywhere. Okay, so that's commands, shortcuts. I now want to talk a little bit about the visual editor. My guess is, and this was the case with me, anybody that tried the visual editor years ago decided that it's just not very good. It puts a bunch of code, it doesn't really work, you're going to struggle with trying to get things lined up the way you want them to be, etc., etc. The tool is much, much better now. Basically, it allows you to drag and drop components from the left-hand drawer right onto your palette, and you can arrange all your components as you want. It also allows, on the right-hand side, these property editors allow you to very quickly select different properties on different components within your UI. So if you have a button and you select it, the properties will allow you to specify gravity or width or any of those things. Instead of needing to type them, you can go through these selection criteria and quickly select whatever it is that you want. But the one thing that I really want to highlight, so let's say that, all right, Mike, that all sounds pretty cool, but I'm a coder. I like to do stuff by hand. You still really should be checking out this visual editor for this bar here, because what this bar allows you to do is within the IDE, it allows you to change the visual style representative of what you're looking at. In addition to, as I have set up here now, and now you'll see, actually you can look at how your app will look on multiple devices. So if you'll see in this screen, I have a 3.2 HVGA image, a 5.1 WVGA, a 10.1 WXGA image, and I can quickly look at exactly how my app is going to render on all of those devices in one place. So the way that you get there is where it's selected Nexus 1, you can go into that menu, and it will allow you to select which of the different images you want to preview your app on. In theory, you can actually make changes in real time and see how that's going to lay out in all of those different image sizes.
So, it used to be a little while back that people used to prototype look and feel with Adobe tools. Do you think the visual editor has gotten good enough that Joel can do that?
So the question is, years ago, people used tools like Droid Draw or some other different tools to stub out their visual UI. Is this good enough now that you don't need to use that? I think the answer is yes. There's a really robust set of things you can do. The other thing I will mention on this is, in addition to specifying different resolution screens that you want to look at, you can also specify API levels, and you can also so you can specify API levels using this selection, or you can use this one to actually look at your internationalization. So if you have enabled, German language, French language, etc. on your app, you can actually select those from this drop-down and see how your app lines up when you're using German characters or something. And obviously that's really important because certain language character sets are bigger than others. And this allows you very quickly to modify your UI and understand exactly how it's going to look, right here, really quick. There's no deploy cycle. There's no fiddling with your phone to change the locale. It's all just right here. So even if you're not going to use the visual editor to drag and drop components and select properties, I would really highly suggest that at least when you're testing, that you bring your app into this visual editor and play with the different resolutions and things. Okay, so we're coming up to the last section, and that's performance testing and performance monitoring. So the first thing that I wanted to make everyone aware of that you might not know is there's something called the tools monitor. So if you type tools monitor from your, if you have Android home set, you don't need to put the path. It will, do you guys know what DDMS is? The different tools that allow you to, Monitor actually allows you to run all the DDMS tools external to Eclipse. So I'm going to show you that, and you'll see that it's exactly the same as DDMS. The cool thing is this would allow you to tell people that don't have the IDE installed, that allows them to run some of these performance tools and introspect some of the functionality without requiring the full IDE install, or importing a project and doing all those tough things that maybe a tester might not want to do, or a project manager. So So you can bring up the performance tools using monitor, like this Android device monitor, or if you're in Eclipse, you can show open perspective DDMS. Okay, so this is what the DDMS or monitor window looks like. You'll notice it on the left. It has a list of devices you currently have running, which allows you to select from all those different devices. On the top right, there's all sorts of different functionality that allows you to introspect different things within your app. Now, DDMS is really designed for in-depth performance monitoring. So this is where you're going to want to inspect how your threads are running, if you have threads that aren't being closed properly, or your heap allocation if you're getting out of memory errors, allocation tracker, where your objects are being allocated within your heap. Network statistics get really in-depth information about what calls are being made when and what kind of data throughput is going through those. File Explorer allows you to, it's a GUI that allows you to look on your phone using, introspect your file system. You can then pull or push files to the file system on your phone using that. Then the emulator is the tab I have exposed. This allows you to set, if you want to set latency on your device, simulate a phone call, simulate a location. This is where you would do that. So some important things that I want to make sure everybody, I guess we already covered most of these things, but the one thing that most people can really use out of this screen, and by most people this is not even developers, is this little icon right here. This allows you to select a device, bring your app up on that device, you press that button and it will take a screenshot of whatever's being shown on your device. So that's super useful because obviously we all need to take screenshots for demos or promotional materials, upload pictures to the Play Market, whatever. This is much easier than trying to press up and power on a phone at just the right time and then trying to get that file off. That's a really useful aspect of DDMS is taking a screenshot. Okay, so I think we kind of already covered those things. The last tool that I really want to talk about that I think people might not be aware of, but is super useful, especially for performance optimization, is Hierarchy Viewer. So what this allows you to do is this allows you to inspect the visual hierarchy of your UI and see where you might have extra layouts. In Android, the fewer layouts, the better. If you have a bunch of nested layouts due to the way that the view is measured and drawn, the more layouts you have, the longer it takes to render. And that's obviously bad. That causes performance problems. So this very quickly allows you to look at your UI on a visual level and see what your hierarchy looks like and try to determine any places where you can optimize. A optimal layout is flat and shallow. This is not as optimal a layout. It's got lots of different levels, and so it really allows you very quickly to see exactly how your UI is laid out and how it's performing. In addition, and unfortunately you can't really see in this screenshot, it actually shows you measurement times in that pop-up. So you can very quickly run the Hierarchy Viewer on your UI, see how long it took to render, make optimizations, run Hierarchy Viewer again, and see how your optimizations affected the layout times. In that project that I referenced previously, I have two layouts. One's called bad layout and one's called good layout. When you look at them on the device itself, they look exactly the same. The buttons are all placed in exactly the same place. The UI does exactly the same thing. However, one of them was written with a relative layout, so it's all very flat and not a lot of nested layouts. The other is written using a bunch of nested layouts, a bunch of linear layouts of horizontal and vertical orientation all mashed together. So I encourage you guys to actually run those two side by side and inspect what a good layout looks like and what a bad layout looks like. The same exact layout in that example runs 20% faster using the relative layout. So again, it looks exactly the same, but as an optimized version, it runs almost a fifth faster.
How many levels of layers is considered optimized?
So the question is, how many layers of layout is considered optimal? And the answer is it depends. You know, there's no hard and fast rules. Layouts can be complicated, and sometimes they require a bunch of different nested layouts. Sometimes that's the only way to get it done, dealing with weights or other things. So the answer is it depends. But the real answer to that is as few as you can get away with.
Better user's experience for less levels.
Yes, the fewer layers, levels of layouts that you have, the better user experience. The faster your UI is going to render, and the less resources, probably takes the same resources, but fewer layouts, more better. Okay, I wanted to just touch on some other performance tools. We're almost done here, so just to let you guys know that. Some other tools that I'm not able to demo here, but I want you guys to be aware of so you know that they exist. First one is OpenGL Tracer. So this, if you're using OpenGL within your app, this allows you to trace very specifically through all of your GL calls so that you can see exactly what's happening throughout your code rendering. I don't do a lot of OpenGL myself. I don't do that sort of graphic stuff, but really, really useful if you're doing OpenGL. Really, really useful to be able to see exactly what it is that you're doing. So again, all these tools are just allowing us to get a closer look at how our code is operating so that we really understand and that we can optimize where it's most effective. Pixel Perfect Viewer allows you to look at very close renditions of your UI so that you can isolate shadow problems or any sort of dithering or other issues that you might have in your UI. Network statistics we already talked about. That allows you very, very close understanding of exactly what's happening with your network calls. You can trace the size of the calls, the duration, et cetera, et cetera. System information gives you a really good overview of your device, the memory it's used, the memory it has available, space on the device, things like that. It shows you that in some really nice charts, so it's a really clear visual representation of exactly what your device is, what resources are available to your device.
Would you be able to provide power information there as well? If you have an app that runs for a long duration of time or a service, background service, and you want to make sure that the battery doesn't get drained within 2 hours, anything that you can recommend for doing that type of profile?
So the question is, if you're dealing with a app that might have might suck battery or might use a lot of power, does the system information provide that? I don't know. I'll look at that in a second. I don't know of a good tool to track that.
Trying to buy a company from India that does it.
There's a company in India that does that?
Yeah, but Facebook isn't going to buy it.
Oh.
Does anyone remember something I? It has an I in it.
Yeah. So real quick, we'll go through these last ones, and then I think we're good to close this out. So Lint is a automated testing tool, basically. It's going to, in your code, as it's live, it will flag certain things in your code that are either wrong or that are just bad. So for instance, like we talked about before, if you're using a hard-coded string within your code, lint will go through automatically and it'll put a little flag next to that that says, hey, you probably don't want to be using a hard-coded string here. And then when you mouse over that, it will give you remediation strategies. And in some cases, we'll actually go ahead and fix those for you. So in this case, lint will highlight that. You will click on that particular string, and then it will provide you the a button that says export this string to XML, to strings.xml. So lint is run automatically. It can also be run as part of your build to flag things. It's much like PMD or find bugs in the Java world. Basically, automated testing tool to highlight patterns and not functional problems, but code problems.
So is there a tool that will tell you like what the minimal Android version is that you should target your app to?
So the question is there a tool that will tell you what the minimum Android OS is to target? And the answer is no, because that's fully dependent on you. You need to decide how you want to, who you want to support. So there's no tool that can tell you that. Now, it obviously depends on the APIs you need to support and your customer base. So, but there's no rules for that. That's completely subjective.
You might write code and it could say, oh, if you want to target an older version, you shouldn't be using.
It will tell you if you have API issues, and it will allow you to. It will tell you if you're using an API that's not supported in the version of the OS you're targeting, actually. So that is one of the things that it will tell you. Monkey is basically a tool that is designed to be if 1,000 tiny monkeys were using your app, pressing it all at the same time. This is basically chaos testing to see if a bunch of different presses happen on your app, what would happen, if it'll crash, if it'll cause issues. Monkey Runner, not at all the same thing. Monkey Runner is a scripting tool that basically uses Perl scripts to allow you to do automated UI tests using this Monkey Runner scripting tool. Really useful. Memory allocation tracker. Now this is an Eclipse tool, but it's built directly into the ADT and allows you to, the tools are built directly into the ADT. You can dump a map profile directly from DDMS. This allows you very, very good inspection into the memory of your app. So it provides all sorts of options to determine how your heap's being allocated, and will also provide a bunch of different options for how to improve your memory. So that's an Eclipse tool, but it's built directly into the ADT and is really a valuable tool to use. The last one that I just want to mention, and we kind of have addressed this on a high level a little bit later, this is a external project, an open source project called Sensor Simulator Project. So we mentioned with emulators, there are certain things that you can't emulate, sensors being for one, motion sensors or touch, other things. This Sensor Simulator Project actually allows you to both record sensor operations and play them back in an automated fashion, or if you just want to simulate sensor operations, meaning again motion sensors or whatever, it'll allow you to simulate those on the emulator. So if you're needing to write functionality that the emulator can't support using sensors, that's a really great project and a really great way to make that happen. Whew. Okay, I think we're done. I did want to make sure that I put some reference points up on the screen for where you can go to learn more about the tools. First one we already put up there is the Android Developer Tools official project site. Tons of useful information there, lots of help articles, and more importantly, they also have their project plan, what they plan on doing, what they plan on supporting. You can put help requests in there, you can put bug requests in there. They're very open about what they're working on and what their plans are, and it's all contained in that on that website. Really, really useful. Stack Overflow, I hope most of the people in this room already know about it. If you have a question, yeah, someone has already asked it on Stack Overflow, and hopefully has answered it. Really useful. There is a Google group specifically for Android developer tools, developers, and there's the link for that. Right now, there's a lot of noise about Android Studio and Gradle in there. So if you're working on either of those two tools, that seems to be consuming most of the messages in that group. But the tools guys, the guys that work for Google on the tools project, they're actively in that group, answering questions and helping people. So it's a great resource for researching things if you don't have the answer. Last really great resource is the Android Developer Tools Essential book, available now from O'Reilly on Amazon.com. Okay, that's it. I think we already answered all the questions. I just wanted to make sure that people have access to the GitHub repo, SlideShare, and then if you'd like to follow me on Twitter or circle me on Google+, I would love to connect. So thanks very much.